In this video, we're going to continue to look at some applications with our quadratic function. And here we're presented with the problem. The height y in feet of a punted football is given by the following quadratic equation, where x is the horizontal distance in feet from the point at which the ball is punted. And the question is, what is the maximum height of the punt? So we want to know, how high is this punt going to go? What is the maximum height? So if we want to look at this, first, that simply means we need to calculate the vertex. Well, if we think about the graph of this particular equation, we know that we have a negative 16 over 20, 25x squared plus 9/5 x plus 1.5. Then we know that we're going to have a parabola that opens down. Now, you could use the calculator to graph this, and if you do, you're going to have to make sure you adjust your window correctly. Now, because we're punting this ball, we're concerned with starting with our x possibly here at 0. And once it is punted, how far is the ball going to go? Well, we know it's going to go out here some distance. And if you adjust your screen, I think on your calculator, if you make this around 250 on the x, you should be fine. And then the y maximum should be around 150. Now, this is just something you'll have to play around with to figure out how to get the graph of your parabola. Now, when we punt this ball, the path of it is going to look something like this, where it is going up and then down. And then over here, this is where the ball hits the ground. If you notice over here, this point where the ball is punted here, notice your parabola is on the y-axis here, and that's because this is where the ball is kicked. In other words, when the punter drops the ball is this high off the ground when it is actually on the kicker's foot. So then it travels up, and then it hits your maximum point here, which is our vertex. Okay, so this is our max point, which is our vertex. And once again there, that would be our h and our k. So this is kind of representation of the function, and this is the path of the football. As it leaves the foot, it's going up to a maximum height, and then it comes back down. Now, there's several things we could find here. This problem just simply says, what is the maximum height? Well, if we're looking for the maximum height, then that just means we're looking for the vertex. Now, are we looking for h, or are we looking for k? Well, here, down here, this is the x. Well, this distance would be our h. This is our x coordinate. We're looking for the height, which is our y over here, which would be our k. So we're looking for how high the ball is going. So really what we're looking for is, we want to calculate the value of k. We want to know what is the maximum height here. Okay, so that is our y value. Now, in order to do that, we probably need to find, first of all, what is our x. Now, you could use the calculator, and we talked about this before. We could use the calculator to calculate our maximum value. You could set your left boundary, your right, and guess. Remember, on the calculator, you'd go into second function and trace. If you hit second function and trace, you can go in and calculate the maximum value here. Now, before we do that, let's look at how we could calculate this by hand. Well, we could simply find our h value, and in this case, remember, this is the x, and we said that is equal to negative b over 2a. Well, negative b over 2a for us is going to be a negative 9/5 divided by 2 times a, which is a negative 16 divided by 20/25. Now, be careful. When you put this in your calculator, remember, when you have all these fractions and we're dividing, this is our main fraction bar here. So if this is our main fraction bar, we need to make sure that we put the entire numerator in parentheses, and we also need to put the entire denominator in parentheses. So That way we're dividing the negative 9/5. This value is being divided by the entire value on the bottom. So make sure you put the entire numerator in parentheses and the entire denominator. If you do that, then we should come up with a value that is equal to approximately 113.9. And keep in mind that's the h value, which is along our x-axis, and this would be in terms of feet. So we're looking at 113.9 feet. Now, is that the height of the ball? No, the 113.9 feet is how far the ball has traveled horizontally. So if the punter is here at 0, the ball has traveled 113.9 feet. But then the question, though, we're looking for is how high. We want to know how high this distance, which would be the y value that's over here. So that means we need to find this k value of the vertex. Well, that's easy enough. We know the x value is here, so we simply need to take and plug this into our function. So that means we're going to take f of 113.9, and we're going to plug that into the function. And we would have negative 16 over 2025. Okay, so this is our function up here, and that's multiplied by x squared, so that's 113.9 squared plus the 9/5 times x, which again is 113.9, and then we have the plus 1.5. So if we evaluate this function at 113.9, we end up with an answer of about 104 feet. So this here is giving us the height. So this is occurring at 104 is the actual height that the ball has traveled. This is the highest the ball will go, is this 104 feet. So that is our k value here is 104, and the x coordinate is the 113.9. So that is our vertex, 113.9 and 104. Now, if you notice for this example, that's all that they asked for. We wanted to know what is the maximum height of this punt. Now, there's several other things we could find. You could actually figure out how far did the ball travel. Well, if we wanted to know how far the ball traveled, then we would want to know this is where we started to kick the ball, right here, and the ball landed over here at this point. Well, if we want to know how far the ball traveled, then what are we trying to find here? This would simply be the x-intercept. So if you find the x-intercept here, that's going to tell you how far the ball has traveled. So that's the total distance horizontally the ball traveled. Okay, so that's different than looking for the maximum height. All right, so for the next example here, a manufacturer of lighting fixtures has a daily production of cost of C equals 800 minus 10x plus 0.25x squared. And C is representing the total cost in dollars, and X is the number of units produced. And the question is, how many fixtures should be produced each day to yield a minimum cost? So here we know we're looking for a minimum value. Now let's go back and identify what we know in the problem and what the variables are representing. Up here it says X is the number of units produced. So I'm going to write that down here. X is equal to the number of units that are being produced. Now, C is the total cost. So C is the total cost. And we want to make note this is actually given in dollars. Now, we know that we have the formula here. C equals the 800. We know this is going to be a quadratic equation. And I would recommend rewriting this. Anytime I have a quadratic equation, I like to put it in descending order with the x squared term first. So I'm going to write this as 0.25 x squared, and that's positive. And then we have a minus 10x, and then plus 800. Okay? Now, when we look at this, we can still identify our A, our B, and our C value. Well, we know based on the A value that this parabola is going to open upward. And that's really a good thing, because if this is opening upwards, then we know that this point here is going to be a minimum value where we have the vertex. And that's a good thing, because up here we're looking at calculating the minimum cost. So that means we're looking for the H and K. Now, for this problem, what does H represent and what does K represent? Well, we have to look closely. Our formula says C equals, and this is based on X. Well, our X, our variables here then would be X, and our Y variable is represented by the C over here, so that is the cost. So H and K in terms of the equation then would be X and C. X is the number of units produced, and C is the total cost in dollars. So if we're looking for this point, then we know that we're trying to find H. And again, with this problem, H is representing our X, which is going to be a negative B divided by 2A. So in that case, then we're going to take a negative B, which would be a negative, and our B is negative 10, so that's a negative 10 over 2 times A, which is 0.25. So then that means here our X, or the H value, is negative 10 would be 10 divided by 2 times 0.25, and that should be equal to 20. Now, once again, keep in mind when you do this, make sure that you put the entire numerator in parentheses and the entire denominator in parentheses. So now we came up with an answer of 20. So over here, this is representing our H, or the X value, is 20. And again, what does that represent? X is representing up here the number of units produced. So does that answer the question? How many fixtures should be produced each day to yield a minimum cost? Well, that answers the question. The 20 is X, which is the number of units produced. So therefore, we need to produce 20 units, and that's going to give us this minimum cost. Now, what if I went ahead and I asked the following question? Maybe I would ask, what is the minimum cost? Now, if I ask what is the minimum cost, then that's easy enough. That means we're looking for C. We're looking for the C value over here. And the minimum cost, then we know what X is. So all we have to do now is take this value and plug it in to the function up here. So that means we would simply have C equals 0.25 multiplied by the 20 units squared minus 10 times 20 plus our 800. So if we know the number of units is 20, that gives us the minimum. Then of course, if you plug the 20 in, that's going to give you the minimum cost. And if you do the calculations here, you're going to come up with a minimum cost of $700. Okay. All right, the next example looks at the total revenue, R, which is earned per day in dollars from a pet sitting service, is given by R of P equals negative 12P squared plus 150P. And P is the price charged. So here P is representing the price charged per pet in dollars. So we have two parts here. Part A wants to know, find the revenue when the price per unit is $4. And B says find the unit price that will yield a maximum revenue. And then it says what is the maximum revenue? So really we have three things that we need to find. So if we look at part A first, it says find the revenue. So that's R, find the revenue R when the price per unit is $4. Well, up here, we know that R is the total revenue and P is the price per pet, the price per unit. Okay, so that is price per unit is 4, so that means here the $4 is our P. And if we're looking for R, then all we have to do is plug this in. So that means for part A, we're simply looking for what is the revenue when P is simply equal to 4. So we're simply going to plug $4 in for P. So that's simply negative 12 times 4 squared plus 150 multiplied by P, which is 4. And if we perform the calculations here, we're going to end up with 408. And that, of course, is the revenue, so that would be $408. So make sure that you have the correct units when you solve these problems. So the revenue, when the price per unit is $4, the revenue is going to be $408. All right, so if we look at part B, now we've got to be careful. Part B actually has two parts. The first part here says find the unit price that will yield a maximum revenue. So we want to find out what is the unit price. Now, the key thing is we're looking for this unit price that will yield a maximum revenue. Now, once again, if we think about this formula up here, if we think about the equation, we have a negative a value. The coefficient of the p squared is negative, so we know that this is going to give us a parabola that opens down. And if we're looking for, again, this maximum, then this is going to be our maximum, which is our vertex, which we know is going to be our h and k. And we know that the h value here is going to be represented by the p, and our k is represented by r, which is the revenue. So for the first part here, we're actually trying to calculate the unit price, which is our p. Okay, so if I bring down the formula here, we have r of p is equal to a negative 12p squared plus 150p. So if we look at this, then if we're trying to find this maximum point, then that means over here we're looking for this h value. But keep in mind, what is our h value? In this example, h is really the p value, okay? Okay, so that's our value over here, the price per unit. So then we know the formula is going to be negative b over 2a. So that means we're going to take a negative 150 divided by 2 times our a, which is a negative 12. So if we have a negative 150 divided by 2 times negative 12, then we're going to end up with a value of a positive 6.25. The two negatives dividing here is going to make it positive. Now keep in mind, even though this is our h, that is representing this p, price per unit. So over here, that gives us 6.25, and that answers the question. Find the unit price that will yield a maximum revenue. So the answer would be $6.25. Now, the second part to the problem says, what is the maximum revenue? So that is, what is the maximum R? So the maximum revenue is what we're looking for. So that means over here we're trying to find this value. Well, we already know what the x value or the p value is. It's 6.25. So all we have to do is take and evaluate the function at $6.25. So we plug in 625 into the equation, and we end up with a negative 12 multiplied by 6.25 squared plus 150 multiplied by 6.25. And if you square this and work out the calculations, you're going to end up with $468.75. So again, that's given us the value over here, which would be the essentially the y coordinate to our vertex. So the x coordinate for the vertex, which is the h, is 6.25, and the y coordinate, which is the k for the vertex, is $468.75.